So for this one, we now see some distribution. We also see some other stuff with the distribution. So here's a mistake we don't want you to make. So we are going to distribute the 10 to the 4x and the negative 5. We do not want you to distribute to the 6x because distribution is multiplication, and we do not distribute where there is a plus sign between this is a term and then this next term. So don't just distribute everywhere. It only goes into the parentheses. So in working with this then, I've got 10 groups of 4x's, so 10 times 4x's, that'd be 40x's. But then I've got 10 groups of, I'm saying that's negative 5 because of the minus sign, right? So 10 times negative 5 is negative 50. You can see that that comes out for me as minus 50 in this equation. And then I can just take the rest of that equation and just drop it because there was no other distribution that was needed. We will see some problems that have double distribution or two sets of distribution, not this one. So now that I've done that, like I said, once we distribute, we should be looking to combine like terms. On those last two examples, we didn't see any, so we went into principles of equality. But this one I do see some. I see, first off, that I can take my 40x's and combine them with my 6x's. That will tell me some number of x's that I have. So that'd be 40 plus 6, which is 46x's. Now those are my x terms. I also see a negative 50 and a negative 2 constants. So that would show as negative 50 minus 2, which is negative 52. And then I can drop the 40. So another mistake that we see at this point is where students combine the negative 50, the negative 2, and the 40. You cannot combine terms across the equal sign unless you're using principles of equality. And that's actually where I'm at. Now again, just to relate this to what we've seen, if you had started with this equation right here, you probably would have solved that with ease. But we see again the need for distribution and combining like terms, which just takes us back to 1.1. It's the stuff we've already seen. It's stuff we should be pretty familiar with and be able to do, even if it's in an equation like this. But now that we've done that, we have this two-step equation that we can solve, and that's what I'm going to do. I'm going to get rid of that negative 52 in green by adding 52 to both sides. And yes, I do need to do it to both sides because it is a principle of equality. So this allows me to take the 46x and drop it. Negative 52 plus 52 is actually 0, and then 40 plus 52 on the right side would be 92, the right side of the equal sign. Last thing I need is, I don't want 46x's. The last thing I need is a 1x. So I can make a 46 become a 1? Yeah, no problem. All I've got to do is take it and divide it by itself. So 46 divided by 46 is 1, but I got to do it to the right side as well. 92 divided by 46 is 2. So I've got to go back up to the top of the equation, right? The first equation that we started with. And I've got to replace not just 1x with 2, but there's 2 x's in that set, right? So I'm going to check here for truthfulness. Okay, so on my calculator, 10 parentheses, 4 times 2 minus 5, close parentheses, plus, and here's the other x, 6 times 2, right? We're replacing the x with 2, minus 2. I push enter, and I get 40. So when I replace the x's with 2, I do, just as planned, I get a true statement. So since it is true, I can take this solution down here and box it in because I know that it made the equation true. It is the solution.